Hello! Today I'm going to show you 3 simple tricks to help you solve impossible power problems easily using the power of estimation. Estimation is just a rough calculation, a way to get answers fast without needing perfect information. You estimate because it makes math easier, and because sometimes you simply don't have enough data for an exact answer. So, the first trick is rounding. It simplifies numbers quickly, even if it loses a bit of accuracy. I won't go too in-depth into rounding, because you should know it. But a good, nice rule of thumb is that you would like to round early if you want easy calculations, and you rather round late if you want things to be closer to the exact answer. So here's a quick example. A farmer estimates that there's 290 cows and 525 goats in a particular pasture. What is the total livestock population? So 290 cows is about 300 cows, and 525 goats is about 500 goats. So about 800 total. Fast and close. Next is Fermi estimation, a method of approximating unknown quantities using logical steps. But how do you use it? Well, you can break the problem into smaller pieces, and you can use simple power of 10 approximations. Although the power of 10 part is optional, but it's recommended to make problems easier. So, a very famous example problem for Fermi problem for Fermi estimation is how many piano tuners are there in Chicago? So let's try to find a path to our solution. Well, we want to find out how many piano tuners there are. So maybe something before that we might want to calculate is how many pianos there are. And the number of pianos is mainly dependent on the number of piano players, which is based on the number of people. So a nice path would be how many people, then how many pianos, and then finally how many piano tuners. Starting with the population, let's estimate about 10 to the power 6 people. This is a power of 10 approximation. 10 to the power 7 is too big. 10 to the power 5 is too small. Now, how many pianos? Well, let's say about 1 in 100 people have a piano because 1 in 10 is, well, too big. And 1 in 1,000 is kind of tiny. So, multiplying those two together, you get about 10,000 pianos. Um, Now let's use that to calculate the number of piano tuners. Let's say each piano tuner tunes about 100 pianos a year. Well then, 10,000 divided by 100 is 100 piano tuners. So the city needs about 100 tuners. And there's exactly 83, which is about the answer we got. Very close. So now I'm going to show you why the power of 10 approximation is unnecessary, but still pretty recommended. What is the area of Nevada in kilometers squared? Think of Nevada as a big rectangle and a triangle combined. And putting approximate measurements, this doesn't have to be power of tens. 500, 300, and 400. You can kind of guess this because the length looks larger than the height of the rectangle, and the height of the rectangle looks slightly bigger than the height of the triangle. Calculating the area gives us about 150,000 kilometers squared for the rectangle and about 100,000 kilometers squared for the triangle, totaling 250,000 kilometers squared. And the exact answer is around 286,000. Pretty close. The third tool is the tyranny of large numbers. This is largely unheard of, but it's basically when huge numbers dominate and the smaller details don't really matter. And it's mainly used to reduce complexity in problems that involve counting many things that depend on many values. Like if it kind of relies on the fact that most of the time larger numbers dominate smaller ones. So if you have like 10 millionaires or 3 billionaires in a room of 15 or 4 people. Um, the average wealth in that room is roughly a million, or in the billionaire case, a billion. This is mainly because the billionaire's money or the millionaire's money is going to be a lot higher than the average people. So an example problem that sounds impossible when you first hear it is, how much does the earth cost in raw materials? But let's solve it using the power of estimation. So first, we want to note that based on the tyranny of large numbers, high-priced, high-quantity things dominate. Because if something's low-priced or has a low quantity, it wouldn't really matter that much in the overall cost. So the mass of Earth is probably around 10 to the power 25 kilograms. And we can estimate the percentage of mass that each of the items have and their price per kilogram. Oxygen and iron make up most of Earth's mass, with about 33% of it. Silicon maybe 15%, and diamonds probably 1 or 2%. Um, the price of oxygen is about 50 cents a kilogram, maybe $1.50 a kilogram for iron, and about $4 a kilogram for silicon, and maybe around 1 million to 15 million dollars for diamonds. So multiplying that all out, you get 2 times 10 to the power 24, 5 times 10 to the power 24, and diamonds is about 3 times 10 to the power 30. You note that oxygen, iron, and silicon have relatively low prices compared to diamonds. And even if diamonds was like $1 million a kilogram, it would still be about 1,000, 10,000 times or 10 to 100,000 times cheaper for to get all the silicon than all the diamonds. So the total is about 3 times 10 to the 30, which is kind of ridiculous. And that's kind of something that you wouldn't be able to solve if you were just trying to like calculate, well, every single item multiplying. Because all we need is an estimate, we can kind of estimate um it based on like the tyranny of large numbers. Um, so we managed to solve a seemingly impossible problem in barely any time. So that's like the power of estimation. It helps you make seemingly impossible or very hard problems into simple and easy problems, like just calculating an area or multiplying out two numbers. Thanks for listening. Bye.